Hello everyone, we are foundation students from Curtin University and this is our physics project video about rotational dynamics, specifically torque and rotational inertia. We hope that you enjoy our video. Okay guys, to begin with, torque is a measure of force that can cause an object to rotate about an axis. An object rotating at constant angular velocity remains rotating unless acted on by an external torque. Torque is calculated by multiplying force used with length of the momentum arm. Okay guys, so moving on, based on the example shown above, this is a spanner and this is the pivot point of the spanner. So as mentioned in the previous slide, when force is applied to the length of moment arm, a torque is produced. Okay guys, so today my friend and I will be doing a live demonstration on how a torque is used in our daily lives. So for this experiment, we will be using a spanner and a bolt and nut from a table. So, just to be clear, this is a spanner and we'll take this endpoint as point A, the tip of this point as point B, and the tip of this point as point C. Okay guys, so as you can see, when my friend places his finger at part A and tries to apply a force at it, the spanner doesn't move because the force is moving in a parallel direction to the length of the moment arm. Whereas, when he places his finger at part B, he somehow manages to move the spanner, but in a very slow and uneven way. At part C, the torque produced is smooth and the spanner moves with ease. This is because the force applied is perpendicular to the length of the moment arm. So guys, this is the first and basic demonstration of torque that we have shown you. Okay guys, so let me just give you all a brief definition on the torque formula. If there is an angle between the force vector and the moment arm, a torque formula is altered. So as shown here, the formula will be force multiplied with the length of moment arm and multiplied with the angle between the force and the moment of arm. So this explanation can be shown in the formula above. So F is force applied and R is the length of moment arm, while the angle value is multiplied with sine. Okay guys, so for our second demonstration for the torque, it's going to be a very simple one. We are going to use the door and explain the concept of the torque behind it. Okay guys, so before we begin, let's identify the points first. The hinges of the door are known as the pivot points, while the distance of the door handle to the pivot point is the length of moment of arm. Now, imagine pushing or pulling a door open. The force of your push causes the door to rotate about its hinges. How hard you need to push the door depends on the distance you are from the hinges. The closer you are to the hinges, the harder it is to push. The force applied on the door is always perpendicular to the pivot point. This causes the door to move in a specific direction. Whereas, the further you are from the hinges, it makes it easier for you to push the door open. Okay, so now moving on to inertia. Inertia is the resistance of the object to any change in its motion, including a change in direction. Inertia is based on Newton's first law of motion, which states that an object will remain at rest and move at a constant speed in a straight line unless it is acted on by an unbalanced force. Inertia comes from mass. Object which has more mass has more inertia. One easy and basic example is the coin drop activity. Okay guys, so moving on to the video above. The coin is in resting position even after the paper is moved. The coin stays at rest just for a moment before gravity acts upon it and pulls it into the cup. That is the basic interpretation of inertia. Okay, so now we will move on to the moment of inertia. The moment of inertia or rotational inertia is also called angular mass, which is the inertia of the rotating body with respect to its rotation. It is calculated based upon the distribution of mass within the object and the position of the axis. Okay, so the moment of inertia can be calculated by measuring the distance from any particle in the object to the axis of symmetry. The distance is then squared and multiplied with the mass of the particle. So as shown here, the formula of inertia is mass multiplied by radius squared. And the SI unit is the kilogram meter squared. Okay, now guys, look at the video and observe it. Which do you think will roll down first? Okay, so basically, this is an experiment to show the moment of inertia within these four items. The filled sphere and cylinder rolls down first because of the amount of mass in it. The hollow sphere and cylinder rolls down slower as compared to the latter because it has smaller mass. The smaller the mass, the greater the moment of inertia. Vice versa also applies for this experiment on the moment of torque. Okay guys, so for our final demonstration for all of you will be about the moment of inertia. This demonstration involves rolling down two cylinders, one with mass and one without. The ramp was homemade by using a wood board and a chair. This shows that the demonstrations involving moment of inertia can be done at home easily. Okay guys, so now let us begin with the demonstration. As you see, the object with more mass rolls down faster compared to the object with less mass. All these objects have the same potential energy at the top, but the time it takes for them to get down the ramp depends on how much moment of inertia. This shows that different objects with different shapes, size and mass have different rotational inertia. Okay guys, so that's the end of the video. I hope you learned something from this video. And lastly, my groupmates and I would like to thank you guys so much for your kind attention, and we hope that you have a great day ahead. Thank you.